Alright, so this particular video is related to algebra, simplifying algebra expressions. Now, the thing is, a lot of students and myself, when I was a student, I don't remember the algebra rules very well, and sometimes I get confused. So what I have discovered is that whatever works in numbers works in algebra, so they should be the same. Algebra is just about using letters to represent numbers, okay? So the rules will apply both for numbers and for the letters, which is in algebra. So, for example, if you're not very sure, like if the algebra that the rule that you want to use is working. So, for example, let's look at question 1 on the screen right here. We have 4x cubed y over 12x squared y cubed. Right, so some students are asking like, can I just cancel? Like, when is it that I can cancel, or when can I not cancel? Now, let's look at what happens if we had numbers. So, for example, if I had 8 over 6, and I kind of factorize the number 8 and 6, I would get 2 times 4. I would get 2 times 3, right? So you notice that 8 and 6 would have common factors. Common factors 2 for both. And because on the numerator is 2 times 4, which is multiply, and at the denominator is 2 times 3, which is multiply. So what we can do is we can cancel the numerator and denominator. So what I'm cancelling is not really like randomly cancelling. So it's because I'm mathematically cancelling. So what I'm doing is because 2 over 2 reduces to 1, right? So when 2 over 2 reduces to 1, so all I'm left with is 4 over 3. So these are equivalent. 8 over 6 is equals to 4 over 3. So as long as it's multiply, we can do the cancel. Now, if you don't believe me, we're going to try it if it is not multiply. So let's say, for example, I have this 2 plus 4 over 2 plus 3, which means I have 6 over 5. Right? So if I were to simplify this and I want to cancel, okay, and let's see if the number remains the same. So then I would end up with 4 over 3. So you can press calculators or check or use your ideas about fractions to check. Is 4 over 3 equals to 6 over 5? Well, obviously not, because 4 over 3 is like 1 and 1/3, and 6 over 5 is 1 and 1/5. So they are obviously very different numbers. So it does not apply, cancel on the numerator and denominator do not apply when you have plus and minus, okay? So only when it's multiplied, then we can do the cancel thing, which comes back to this particular question. 4x cubed times y, 12x squared times y cubed. So they are actually multiplies. Because of the way you write it, is actually this. Okay. Now, since they're all multiplying each other, so when we do the so-called cancel, then we are actually reducing them to 1. So what happens is 4 and 12. So we are simplifying. So 4 divided by 4 is 1. 12 divided by 4 is 3. Right? So we're basically reducing the fraction of 4 over 12 to 1/3. And given that x cubed, so x cubed is actually x times x, and x squared at the denominator is just x times x. So if I actually cancel, I'm actually reducing them to 1. So I'll end up with 1x over here, right? Then, therefore, when I so-called cancel, I would have x over here. And when I cancel, okay, because I have a y cubed at the denominator and y at the numerator, so therefore I will have a remaining of y squared. So my final answer for this would be x on the numerator, 3y squared on the denominator. Right, so this sounds relatively okay. So let's look at another situation whereby it may not be so clear. Okay, let's make space for that. So let's look at number 2. So number 2, we have 5a plus a squared and over 6a squared at the denominator. And students would ask, can I do this like cancel? Okay, so check this out. We have plus over here. So remember the rule that we tested out earlier on the right hand side? Over here. Yep. So, which means that in this case, we can't cancel the a, but what we can do is factorize first. So simplify is one way to simplify an algebraic expression is to factorize. So we're going to take out the common term or common factor of 5a and a squared. So as you can see, we have an a here, and a squared means a times a. So which means I will take out a as the common factor, and I will have left with 5 plus a. So mentally, I would check a little bit, like if I were to multiply a times 5 and a times a, would I get back the original expression? Okay, yes, I will. So do remember to just imagine or visualize the checking in your head. Or if you want to do, actual checking or working, that's fine as well. And we have 6a squared. Now, notice that at the numerator, you will have a times the whole bracket of 5 plus a. And at the denominator, you have 6 times a squared. Okay, I'm going to just write this extra step. You don't have to do that if you're very familiar eventually. So we have a times 5 plus a, okay, and we have 6 times a times a. So if everything is multiplying, so we have to see this bracket as a whole. Okay, we can't do anything inside because it's plus, but we can see it as a whole, right? So a and a can be reduced to 1 because it's multiplied here. Everything is multiplied. So on the numerator, I would be left with 5 plus a divided by 6a. Okay, so now, can I still simplify further? Okay, no, I don't think so, because this plus, right? So remember the rule that we tested out on the right side. So remember this, if you cannot cancel yet, so one of the ways is to check if you can factorize it. Alright, so I hope this helps. Thank you so much.